Hi everyone. Today we're going to be looking at another factoring technique, which is called difference of squares technique. So, in your notebook, I would like you to put today's subtitle, which is difference of perfect squares technique. This technique is extremely fast, assuming that you can train yourself to be able to recognize when you're allowed to use this technique. So, I would like to take you back a few classes to when we looked at different binomial identities. I want to look at one in particular, the product of two conjugates. So in your notebook, I want you to skip a few lines and put down x plus 5 multiplied by x minus 5. If you remember from that identity, if you apply the shortcut, we would get x squared minus 25. If you can consider that the multiplication is considered going forward, then the reversal, going backwards, can be considered the factoring. But the big question is, how would you have recognized that the x squared minus 25 could be factored into two conjugates, x plus 5 multiplied by x minus 5? Well, let's take a look at the x squared minus 25. This is in fact a very special binomial, and the subtitle says it all. This binomial is known as a difference of perfect squares. Why? Well, the first word difference is your biggest clue. It's a subtraction. Well, it's a subtraction between two terms, and the two terms, the 25 and the x squared, are both what we call perfect squares. But what makes them perfect squares? Well, that's easy. The definition of a perfect square is any monomial that can be broken down into the product of two identical terms. For example, the 25, that can be broken down into 5 times 5. The x squared, that's considered a perfect square because it can be broken down perfectly into x multiplied by x. Let's look at other possible perfect squares. X to the 4. That's a perfect square because that can be broken down into x to the 2 multiplied by x to the 2. X to the 6. That's considered a perfect square because that can be broken down perfectly into x cubed multiplied by x cubed. How about this one? 25x to the 12. Well, that's also considered a perfect square because that can be broken down perfectly into 5x to the 6 multiplied by another 5x to the 6. Have you noticed a pattern about when a variable is considered a perfect square variable? Congratulations to you if you realize that a variable can be considered a perfect square if it has an even exponent. So, now that you're able to recognize when a monomial is considered a perfect square, how does this apply to this particular factoring technique? Easy. Once you put example, Suppose I were to give you this question. Factor the polynomial 16x squared minus 25. Well, before you're able to apply this factoring technique, you must establish that this polynomial is in fact considered a difference of perfect squares. Well, the subtraction is there, so it is a difference, and both terms are considered perfect squares because the 16x squared can be broken down perfectly into 4x times 4x, and the 25 can be broken down perfectly into 5 times 5. Once you've established that the 16x squared minus 25 is in fact a difference of perfect squares, this is how the factoring technique works. 16x squared minus 25 equals, what I usually do is I set up my two brackets because I know it's going to be factored into two conjugates. And inside the brackets, all you have to do is this. Take the first term, the 16x squared, and square root it. So that gives you 4x. Put the 4x in both brackets. Next, take the second term, the 25, square root that, giving you 5. Put the 5 inside both brackets. And the only difference between them is one bracket is a plus and the other bracket is a subtraction. As you can see, this factoring technique is extremely quick. Again, assuming that you're able to recognize that the polynomial 16x squared minus 25 is a quote-unquote difference of perfect squares. Let's look at another example. Why don't you put EX? Suppose I give you this question. Factor 49x squared minus 16y to the 4th. Well, again, first you must establish that this is in fact a difference of perfect squares. Well, there's a subtraction sign, so it is a difference. 49x squared can be broken down perfectly into 7x times 7x. And the 16y to the 4 can be broken down perfectly into 4y to the 2. So this is in fact a difference of perfect squares. Therefore, we may apply this factoring technique. Put equals 49x to the 2 minus 16y to the 4 equals, again, I usually put the two brackets first, and let's fill in two brackets. The square root of 49x squared is 7x, and the square root of 16y to the 4 is 4y squared. And then put a plus in one of the brackets and put a minus in the other one. Done. Let's try one more, and I'll guide you through this one. Suppose I'd like you to factor this one. Factor 36x to the 4 y to the 2 minus 81 z to the 6. One more time. You must first establish that this is in fact a difference of perfect squares. Well, there's a subtraction sign, so it is a difference. 36x to the 4 y to the 2 can be broken down perfectly into 6x squared y multiplied by 6x squared y. And the 81z to the 6, that can be broken down into 9z to the 3 multiplied by 9z to the 3. So, this polynomial is in fact a difference of perfect squares. So let's apply the technique. Equals 36x to the 4 y squared minus 81 z to the 6 can be factored into, and again I like to put my brackets first. Now let's fill in the bracket. So square root of 36x to the 4 y to the 2 is 6x squared y. Put another one in the second bracket. And the square root of 81z to the 6 is 9z to the 3. Put another one inside the second bracket. And one bracket contains a plus, the other bracket contains a minus. I think it's time for you guys to try one on your own. So I would like you to put EX. Alright, I want you to factor this one. Factor. We'll start you off with an easy one. How about 25x to the 8 subtract 100y to the 4. Go ahead, I would like you to pause the video and try it now. Alright, let's see how you guys did. Well, first I'm going to establish that this is in fact a difference of perfect squares. The subtraction is there, and 25x to the 8 can be broken down into 5x to the 4 times 5x to the 4, so that's okay. And the 100y to the 4 can be broken down into 10y squared multiplied by 10y squared. So that's also a perfect square. Good. So let's apply the technique. That means that 25x to the 8 minus 100y to the 4 can be factored into 5x to the 4. The second term is 10y squared. And one bracket has a plus, other bracket has a minus. So, how'd you guys do? Great! Let's try one more on your own. A slightly tougher one. For example, I want you to try factoring this one. Factor. So let's give you a whole bunch of variables now. How about 121 x to the 6 y to the 4 minus 16 z to the 8. Alright, I'd like you to pause the video and give it a shot. Alright, let's see how you guys did. So, is this a difference of perfect squares? Yes it is, there is a subtraction. 121 and 16 are both perfect squares. And all the exponents on all the variables are even. So, everything is a perfect square. Let's apply the technique. Equals. And most people don't need to recopy it. Most people simply go straight to the brackets. Alright, let's fill it in. The square root of 121 x to the 6 y to the 4 is 11 x to the 3 y to the 2. And we'll put another one in the second bracket. And the square root of 16z to the 8 is 4z to the 4. Put another one in the second bracket. And then plus and minus. So, how'd you guys do? Great stuff. So, this is known as the difference of perfect squares technique. I'll see you guys in class tomorrow.